For some absolute value, AB, I'll shorten for absolute value equations, not in the form that we discussed, which was absolute value of some expression is equal to k. So for some equations not in this form, we need to isolate, okay? Now not isolate the variable, but we need to isolate the absolute value expression. And now I'll show you what I mean by that in an example. It's not too hard. Example 1. Suppose we have 2/3 x plus 3, absolute value, plus 4 is equal to 10. Now notice, does this thing match this form that I talked about before? Do I have the absolute value all by itself on the left and a number all by itself on the right? No. So I need to get it to look like this before I can solve it. So what do I need to do here? Yeah, just subtract the 4. 2/3 x plus 3. Subtracting 4 gives me 6. Then from there you bust it up into the equal to 6 and negative 6, and then you can solve it. Let's look at this one. Negative 5. Absolute value of 2/3 x plus 4 plus 1 is equal to 1. Now this one might be, we need to think about it a little bit. What is this negative 5 in front of the absolute value symbols? What does that actually mean? Multiply. So it's negative 5 times this thing. And then we're adding 1, and that's equal to 1. So whenever we want to solve these equations, what do we do first? Do we divide, or are we going to subtract? Like if we were just solving a linear equation, subtracting I think would be easier. You could actually divide by negative 5, but you have to remember to do that to everything. But I think subtracting is easier. Subtract the negative 1 from both sides of the equal sign. Then I still have a negative 5 absolute value of 2/3 x plus 4 is equal to 1 minus 1 is 0. Now I can divide by a negative 5. Okay. I've been thinking about, I want to make a video detailing this process. I know this could be some of the most challenging parts about solving equations, is how to know when to subtract or divide, and when can you cancel out, and things like that. But notice that on the top, I've got negative 5 times this expression. Whenever I've got a multiplication, these two things are factors. Okay? When they're factors, that is when you can cancel them out. Okay? When they're terms, which means they're connected with addition or subtraction, you could not cancel them out. So what have I got left on the left-hand side? 2/3 x plus 4 is equal to, what is 0 divided by a negative 5? Just 0. And now we can solve this. It's actually easier than the rest. Why? Going back to when I break it up into a k here is 0, is there a difference between a positive 0 and a negative 0? No. So really, all we have to do then to solve this one is 2/3 x plus 4 is equal to 0, and solve that one equation. Okay, and I'll let you guys do that. If you want me to do it after class, I'd be happy to do it. So let me show you an example of going back to what I was talking about. Suppose I had this, negative 5 plus the absolute value of 2/3 x plus 4 is equal to 0. Notice how similar this looks to this, the example that I just did. Okay, and if I divide by negative 5, I cannot cancel here. Okay, and the reason is because you look at how this negative 5 is connected to this absolute value. How is it connected? What's its relationship? It's added. This one is multiplied. Okay, that's why when you divide by a negative or divide by a number that's multiplied, you can cancel. But if you divide by a number that's added to something, you cannot cancel. Okay? I mentioned that on Thursday. I will continue to mention it because it's a very common thing, and I really would like for to be able to show you that. And I'll try to come up with some other examples. Okay? Any questions? Everyone see what the difference is. Here I'm multiplied, so when I divide I can cancel, but here I'm added to this thing, and so when I divide I can't cancel. In fact, I can't do anything much with this. Actually made it more complicated by doing it this way.